4, continued. So we're still talking about rational exponents. When we talk about rational exponents, those are those fraction exponents we have, right? And if we have a fraction exponent, I have a fraction here. Remember your fraction exponent always power over roots. Now we're going to be able to use that a lot. Now before we get into that, I think it's important that we talk about some of our exponent rules. So we haven't talked about them in a couple years. Okay, so talk about those exponent rules. First of all, the exponent rule where we have x to the 0 power. What does that equal? 1. Very good. All right. What about if I have x to the negative n? What does that negative mean I have to do again? Good. 1 over x to the positive n. What if that's on the bottom? What if I have x to the negative n on the bottom? What does that do? We move it to the top and the n becomes positive. All right, what if I have x to the n times by x to the m? So I have two bases that are the same. The rule says we keep the base, and what do we do with our exponents? Add them. N plus m, we're going to add them. If I have x to the n divided by x to the m, what does that mean for our rule? You're going to subtract them. So we keep the base, and you subtract the top minus the bottom. And the last exponent rule is if I have x to the n raised to the m, what do I do with my exponents? You times them. So we keep the base and we multiply our exponents. This is nm. Right? So today, all of those rules are going to be really important as we move forward. Okay? So, example number 1. Let's just jump right in. For example number 1, let's say I have the 4th root of 18 times by the square root of 12. So these are different size radicals, aren't they? Yeah, go ahead. Oh, thank you. However, we can change these so that they are the same size radical. So we can actually, and I'm going to use the 12 for example. This is 12 to the 1/2. What can I do to that 1/2 exponent to make it a 4 in the denominator?
2 over 4.
Yeah, it's the same as 2 over 4, isn't it? Right? 1/2 is the same as 2 over 4. So I can rewrite the second radical as 12 to the power of 2 inside a 4th root. So I would have the 4th root of 18 times by the 4th root of 12 squared. Now, because they're the same size, we can multiply them together, right? All right, so we're going to do the 4th roots. Go ahead and multiply them together to start. Let's go 18 times 12 times 12. Somebody throw that in the calculator for me. 2,592? All righty. All right, now we just got to simplify that, right? Now, I probably, just because we already had that above it, we're going to split it into, let's go 18 and 144. All right, let's go 18 is 2 and 9. 144, let's go 12 and 12. Okay. 9 breaks down into 3 and 3. 12 breaks down into 2 and 6. And this 12 is 2 and 6. And 6 is 2 and 3. All right, so we have everything broken down. Okay, so this is inside a 4th root, so how many of the same thing do I need? 4. So start with, I have 1, 2, 3, 4, 3, so I can take out a 3. And we have 1, 2, 3, 4 2s, so I can take out a 2. When they both come out, what do we do with them? Times them together. Very good. So 3 times 2 is 6. 4th root. What is left over? A 2. That's it. So I know like a week and a half, 2 weeks ago, I told you couldn't multiply those together. Now you can. Right? We just have to change the size of the radical. Let's do example number 2. Yeah, these are in that first section. Yep. All right, let's say I have the square root of a to the 4th b divided by the 4th root of a to the 2nd b to the 8th. All right, so right now we can't reduce that fraction like I told you to do before because they're different dimensions, right? So we have lots of different possibilities of what we could do. What I'm going to recommend is when you hit a situation like this, let's change them into fractional exponents. Okay? So starting on the top, this a is actually a to the 4th power inside a square root. So that is a to the 4 divided by 2. All right, let's do the next one. This b is b to the 1st power inside a square root. Divided by. On the bottom, we have a to the 2nd power inside a 4th root, or a to the 2 over 4. And b is to the 8th power inside a 4th root. Now look at all those fractional exponents. Can we do some stuff with them? We can reduce them, can't we? This first one, 4 divided by 2, it's just 2. How about this one down here? 2 divided by 4, 1/2. And this one, 8 divided by 4, is 2. All right, let's rewrite it now that they're a little bit simpler form. We have a squared, b to the 1/2, over a to the 1/2 b squared. Why would you flip them? What do you want to do?
You can do a to the 4, b to the 1 to the 4.
You could. That's one option. Why don't we write them down as radicals and see what happens? Okay, and then maybe we can come up with another option. Or there's lots of different options, but let's see. So this a squared, is that going to be inside a radical? No, it's just a squared, isn't it? So I do have b to the 1st power inside a square root. Over. On the bottom, we have a to the 1/2, which is a to the 1st inside a square root. And we have b squared. So b squared is on the outside. Do you guys agree? So then, in this case, what's the only thing we really have to do?
Times the other one by a squared.
The square root of a?
Square root of a.
Square root of a, I agree with. How many times by the square root of a? And whatever I do to the bottom, got to do to the top, right? So on the top, on the outside, I still have a squared. Inside that square root, I have ab. On the bottom, I have b squared. And what's the square root of a times the square root of a? A. Good. Now what's the only thing left to do? Yeah, we can reduce those a's that are on the outside, can't we? We can get rid of this one with one of them here. So our final answer would be a square root ab over b squared. Is that the only way to get that answer? Nope. You could have subtracted exponents. You could have, I mean, lots of different approaches will get you to the same exact place at the end. Depends which way makes the most sense to you. Okay? Questions so far? All right. Let's go to example number 3. In the next section, 48 through 54, it is asking you to simplify. So if we are simplifying something as wonderful as, let's say, 64 to the 2/3 times by 64 to the 2/3. Well, using our exponent rules, what's one thing we can do? Yeah, we have the same base, so we can put 64 and add our exponents together, which is 4/3, right? Then what can we do? Huh? Now we can write them as a radical. I agree with you, Irene. So this is actually going to be 64 to the 4th power inside a cube root, right? Yes, we can take a group of 64s out. We can do that for Irene back there. We have 4 cube root 64. Now can we break down 64?
I think so.
You know 8 times 8? Sure. Oops. We can do 4 and 2. We can do that. 4 and 2. That 4 is going to be 2 and 2. All right. So here we have 2, 4, 2 and 2. So in this case, we need groups of 3. So we have 1 group of 3 2s, and we have 2 groups of 3 2s. So that actually means we have 4 that gets to come out, right? We're going to multiply with a 64. 4 times 64? 256. Is there anything left to put back inside that cube root? Nope. Easy? All right. I'm glad you think so. Example number 4 then. Last section, let's talk about the 56 through 66. All it's asking you to do is to simplify or to write the expression in simplest forms. So again, some of those exponent rules might come in handy. So for example, if I had, let's say I have x to the negative 3/5 raised to the 5th. Our exponent rules tell us an exponent raised to an exponent. What can we do with those?
It's -3.
Because you did what, Gabe?
Times them.
All right, yeah, so we're going to multiply our exponents. We get x to the negative 3, and then what do we have to do with that? Flip it. Right, we got to move it to the bottom. So we end up with 1 over x to the 3rd. You want a harder one? Now, let's do one more really quick. And then I'll stop. You'll be fine. How about if I have, let's go with x to the negative 2/3 over y to the negative 3/5, all raised to the 15th power. All right. So remember, when you have an exponent outside that parenthesis, you got to give it to everything inside the parentheses. So it's got to go to this one, and it's got to go to that one. And an exponent raised to an exponent, we multiply, right? All right, so that's our first step. On the top, we have x, negative 2/3 times 15. Negative 10, good. Over, on the bottom, we have y, negative 3/5 times 15. Good. Now what did we say about our exponents? If they're negative, they got to flip. So this x to the negative 10 is going to go to the bottom, and the 10 becomes positive. And that y to the negative 9 goes to the top. It becomes y to the positive 9. This is it. That's done. Okay? Any other questions? All right. So you guys still have like 11-ish minutes that you can go ahead and get started on this assignment.